Okay, hello again. Welcome to the video, the balance of the review sheet. Numbers 18 through 25. Okay, so the challenging ones. Sort of. In that these ones, sort of 18 through the next five or so, are still relatively easy before they get challenging. Okay, so let's take a look. 18. Negative k to the, let me get my pen going on here right quick. Okay, negative k to the fourth over, or negative h to the fourth, j to the third, k to the fourth. Okay, so first of all, let's deal with the, all right, so are there any negative exponents? No, not entirely. No negative exponents here. What we have to do, the only simplification that involves combining variables here is the division of k to the fourth and k to the fourth. So this, if I just bring this out, or just show on the side, you can think about this as k to the 4 minus 4 is k to the 0, which is just 1. But also, any number by itself is just simply 1. Note as well, the coefficients to h here is 1 and k is 1. So when I divide these k to the fourths, right, they cancel, and the negative 1 that is the coefficient is one of the products in the numerator, meaning that this numerator is really, and I'm going to, no, I can rewrite it. I can write it here. I have the room, is negative 1 times k to the fourth over negative 1 times h to the fourth times j to the third times k to the fourth, right? Let me extend my fraction bar here this way. So these negative 1s here, this negative 1 stays. When I divide k to the fourth by itself and get 1, the negative 1 remains. So my result after that, negative 1 over negative 1 h to the fourth j to the third. Now, negative 1 over negative 1. You should always think about the coefficients in the numerator and denominator as a fraction that simplifies. Does negative 1, or ask yourself if it simplifies. Does negative 1 over negative 1 simplify? Yes. Their common factor there is negative 1. So if we divide both by negative 1, we get 1 over 1 or just simply 1. So for that reason, we can think about these coefficients as just dividing by themselves and then, or sorry, dividing, yes, as a number divided by itself, which divides to 1. Okay, good. So now, it's not that there's nothing that remains in the numerator. Just because we did the negative 1 divided by negative 1 and made it 1, the 1 remains. So my final answer, 1 over h to the fourth, j to the third for 18. Okay. 19. Negative, the negative fraction, 2b to the fourth over 2b to the fourth. Now, this could be something that you could just visually see right away. A negative and then a fraction that's just a exact same thing divided by itself is just simply negative 1. But we can also follow the exponent rules here, and that keeping the negative 2 over 2, right? B to the fourth and b to the fourth, these divide out to 1. So that's just ends up being negative 2 over 2, right? Which is, what's 2 over 2 simplified to? 1 over 1 are 1. Final answer 1. Easy one there. 20. Negative 4 over 4, negative 4r to the negative 1 over 4r squared. Okay, so here we have the negative exponent, I believe for the first time here. So this r to the first, right, because it's in the numerator, it bumps down to the denominator. So the 4 stays, and we can rewrite the denominator as 4r squared r, right? Because or r to the first, because this bumped down to the denominator and then turn positive. We can then combine these r's in the denominator here by adding their exponents, because this is the product of power. So this is negative 4 over 4r cubed. Simplify the coefficient here. 4 over 4 simplifies to 1. So, or divides to 1 here. So I keep my negative, and because I haven't canceled out everything in the numerator, no, what remains is always going to be 1. So that's 1 over, or so I should say negative 1 over r cubed for 20. 21. Okay, so same sort of thought here, and that this negative 4x y to the third, and I'm just rewriting this, I don't know why I'm doing that, and negative 2xy to the third, These y to the third over y to the third divide to 1. X over x divides to 1. Well, I'm just simplifying negative 4 over negative 2. That common factor there is negative 2, so divide both by negative 2. My final result, 2 over 1, or 2. 22. Okay, so here we dealing with our negative exponent, this entire term. Note, not the 3. The 3 doesn't come along for the ride. 3 is not being raised to the negative 3 power, only x is. So the 3 stays in the numerator. We have x to the fourth, z squared, and then x to the third. That's this x to the third from up here, and then I made the exponent positive. So I can then combine these. I'm just going to rewrite it so that it's obvious what we're looking at here. X to the fourth times x to the third times z squared. And I rewrote the x's next to each other, so I know I need to combine them. So this becomes negative 3 over x to the seventh z squared. Okay, now we start having some difficult powers. Okay, so this is the first problem that involves this power rule, the power of a quotient. A to the b raised to the m is a to the m over b to the m, meaning that anything that I'm any fraction I'm raising to a power, I'm just raising everything, all of the products in the numerator and all the products in the denominator to that power. Now, I should probably simplify as much as possible inside the parentheses first, because that's what follows my order of operations. So I do so like this. I'm keeping my negative fraction. Anytime I see a 0, that's the first thing I'm going to do is just eliminate it. It's not canceling, it's that it's just equal to 1 and we don't have to write that. So my result here, a to the negative first over 2, all raised to the fourth power. Now, a to the negative. My suggestion would be to make that positive and put it in the denominator. Because this is a negative 1, this goes down to the denominator here. This becomes 1 over 2a. And so this a to the first, now note this a, negative 1, this exponent is now positive, so it becomes 1 over 2a, right, raised to the fourth power. So now I have this 1 over 2a. What remained after the a to the negative first went down? 1 remains. 1 always remains. This, and now it ends up in the denominator, and now I have to raise everything to the fourth power. So what's my result? 1 to the fourth power, 2 to the fourth power times a to the fourth power. I wrote 2 there, but I meant to put a 4. Okay. And that fraction bar extends to over here. That's 4. Okay, so I raised everything to the fourth power. 1 to the fourth power is just 1. What's 2 to the fourth power? 16. What's a to the fourth power? A to the fourth. So the final answer is 1 over, and you know what? Actually, let me say this. This negative, now that I'm seeing this, I actually forgot this negative here and dealt with it. You can apply this negative to the 2 or the 1. I'm going to choose to apply it to the 2 because I already have the parentheses here. But note that, and that follows from this rule here, and we went over this in class, but negative 2 over 3 is equal to 2 over negative 3 is equal to the fraction negative 2/3. So this negative can either be put in the numerator or denominator. I'm going to choose to put it in the denominator and tag it along with this 2. Negative 2 to the fourth power is also 16, so this answer is still true. 1 over 16 a to the fourth power. Okay. 24. All right. So here, what we need to do first is deal with these negative exponents. Now, this negative 1, what does this mean, really? I would bump this entire thing down first. So when I mean bump down, because this entire term in parentheses is being raised to the negative first power, that means actually that it's the entire thing in parentheses is being bumped down. So this is negative 2n to the third, raised to the first power, but we just won't put that. So we have to evaluate this now. Okay, negative m squared to the third power. Now, this is really having a coefficient of negative 1. So the way that I want you to consider this is ostensibly negative 1 raised to the third power, because these are the two products inside the parentheses, times m squared raised to the third power, and then times negative 2n, or they, sorry, times negative 2, that's the one of the products is that coefficient times n to the third. So I want to simplify everything in my denominator, raise these both to a power, essentially. So this is negative m cubed, always staying in the numerator, negative 1, because negative 1 raised to the third power is negative 1, m to the sixth. And then we'll say this is still, so times negative 2 times n to the third. Okay, so we have a lot of things going on here. We have this negative outside, we have this negative and that negative. Like I said in the previous problem, I'm going to move this negative, or choose to move this as a negative 1 in the numerator, just to make it a little bit more simple looking. So let's rewrite it as such, and still being products. Okay. All right. So how do we simplify here? M to the 6th and n to the third can't be simplified. They have to stay. But negative 1 times negative 2 can be simplified. That's just simply, and I'm going to make this negative 1m cubed, positive 2. So this ends up being 2m to the 6th n cubed. Okay. Now, the only thing left to do is this negative 1 just gets pulled outside the fraction. If you write this as negative m cubed over 2m to the 6th n to the third, I won't be mad. But in the answer key, note that the negative sign will be sort of next to the fraction to make it a negative fraction and look something more like this. Negative m cubed over 2m to the 6th n cubed. Okay, so yeah, then this makes sense because this is essentially the fraction 1 over 2, which can't be simplified. So this 2 stays in the denominator. Okay, last one. Most difficult looking one, but that's okay. All right, first thing I'm noticing, x to the 0, that disappears. That ends up being 1. Let's simplify and combine in the numerator. So this is 2 times negative 2. And I'm going to do this work in my head just to show you that it's possible. For the longer one, I won't write this out completely. My z terms, I'm combining and adding exponents. So that ends up being, actually, let me put in this y cubed first. That ends up being z to the 6th power over, and then we'll call this negative 2 y cubed z squared, keeping everything. Now, can I simplify in the numerator denominator? Absolutely yes, because I can simplify these y's and z's by subtracting exponents, also simplifying negative 4 over negative 2. So I'm going to do all that at once. Negative 4 over negative 2, well, that's just simply 2. Negative 4 divided by negative 2 is 2, so that stays 2. It's over 1, but we'll just keep 2 in the numerator. We have y to the third power divided by y to the second power. So that ends up being y. 3 minus 2 is 1. Z to the 6th divided by z minus 2. Z to the 4th. Now what's left in my denominator? Nothing. In fact, I'm going to rewrite this so I don't have to put anything in my denominator. Oh, I totally erased more than I wanted to. That's okay, I'll rewrite it. So my final answer, really, I'm still having everything being raised to the 4th power, but it's just 2y z to the 4th raised to the 4th. So I'm raising all these to the 4th power. 2 to the 4th is 16. Y to the 4th, z to the 16th is my final answer. Okay, that concludes my video. Hopefully everybody's studying hard, and I will see you in class tomorrow. Good luck.